Hello students, last class we discussed about some conversions. Here now let us discuss some analytical question. So for this analytical question, you have to remember all the chemical properties and preparation methods of preparation of compounds, and you have to also remember all other related chapters with amines, that is carboxylic acids, aldehydes, ketones, alcohols, alkyl halides, ethers, etc. Next, you have to read this question first 2 to 3 times. Then you have to find out what is the clue here. So first, if any formula is given, any reaction given, any formula given, so first you have to find out the clue here, and from that you can solve this whole question. Okay, look here. A hydrocarbon A C4H8. From that we can know this is an alkene. On reduction with dilute HCl gives a compound B C4H9Ca. So this is C4H8. It may be butene. So it may be butene. It may be but 1 or but 2 So what is actually this is? Which on reduction with 1 mole of ammonia gives a compound C. Again C4H11, and so this is an chloroalkane, and chloroalkane reacts with ammonia. That means it must be an amine. On reacting with NaNO2 and HCl followed by treatment with water, compound C gives an optically active alcohol D. So this is an alcohol. Amine reacts with nitrous acid to form an alcohol. So what is that alcohol? That is butane 1-OL, butane 2-OL, or any other alcohol. But that is given optically active alcohol. That means that is your butane 2-OL. This one is optically active. Ozonolysis of A gives 2 moles of acetaldehyde. As A on ozonolysis gives 2 moles of acetaldehyde. Identify compound A to D. Explain the reaction. So this is the clue actually. Ozonolysis of A gives 2 moles of acetaldehyde. As ozonolysis it gives 2 moles of acetaldehyde. Then what is our A? So this is our 2 moles of acetaldehyde. So from that we conclude that, that alkene A is but2ene. So hence A is, so this is on ozonolysis we get, followed by hydrolysis. So in this way the alkene is but2ene. This is A. Again but2ene. So first you have to write the point. As ozonolysis it gives as ozonolysis of A gives 2 moles of acetaldehyde. That means 2 moles of acetaldehyde. That means A must be but2ene. Next, so again what happens when this reacts with HCl? So if it reacts with hydrochloric acid, then what happens? Addition reaction takes place. Bond breaking takes place. To one side hydrogen, to another side chlorine. So it forms CH3, CH2, CH, CH3, Cl. This is 2-chlorobutane. 2-chlorobutane. So this is your compound B, and this on reaction with ammonia. So when it reacts with ammonia, alkyl halide reacts with ammonia. So removal of minus HCl, your HCl takes place, and it forms a primary amine CH3, CH2, CH, NH2, CH3. This is 2-amino butane, or you can say butane 2-amine. butane to amine. And butane to amine when treated with nitrous acid. When this is treated with nitrous acid, HNO2. That is, actually this is treated with sodium nitrite and HCl. NaNO2 plus HCl give rise to nitrous acid, and when this is nitrous acid treated, it forms an optically active alcohol CH3, CH2, CHOH, CH3. So this is A, this is B, this is C, and this is D. So you have to write also what are the points. So first, as A on ozonolysis gives 2 moles of acetaldehyde, that means A must be alkene and this must be but2ene. Then but2ene reacts with hydrochloric acid to give 2-chlorobutane. You have to write the points also. Then 2-chlorobutane reacts with ammonia to form butane to amine. And butane to amine again treated with this to form sodium nitrate and HCl to form butane to OL. This is your butane to OL. Butane to OL. So this one only in containing 4 carbon atom. Alcohol containing 4 carbon atom, this one only optical active because this carbon is a chiral carbon and it is attached to 4 different groups. One side OH group, one side hydrogen, one side ethyl, one side methyl. So this one is optical active compound. So then you have to write this whole equation, and this type of question generally carry 3 marks or in sometimes 5 marks. As it carries 3 marks and 5 marks, don't write only the equations. You have to write the points, then write down the overall equation. Okay. Next come to question number 2. So here starting compound is given, that is acetylene. Acetylene reacts with dilute sulfuric acid in presence of HgSO4 to form compound A, which reacts with ammonia in presence of sodium cyanoborohydride to give compound B. The compound B, when treated with chloroform in presence of alcoholic potash, produces unpleasant smelling compound C. Identify A, B, C. So first compound is given acetylene. Okay, CH triple bond CH. So acetylene when reacts with HgSO4 in presence of H2SO4, actually hydration takes place. So it reacts with water. If this reagent is used, then acetylene reacts with water. So it reacts with water to form CH2 double bond CHOH, which undergo tautomerization to form hydrogen here and this bond here to form acetaldehyde. This is acetaldehyde. So this is compound A, acetaldehyde. Then A reacts with ammonia. So first acetaldehyde reacts with ammonia to form, to this ammonia I can write H2NH to ammonia. So removal of water takes place. It forms an amine, CH3CH double bond NH, acetaldehyde amine, acetaldehyde. This is acetaldehyde. And this, when treated with sodium cyanoborohydride, it undergo reduction, NaBH3CN. So if this reagent is used, this acts as a reducing agent. It reduces acetaldehyde to an amine. So in this way bond breaking takes place here. It forms CH3CH2 NH2. So to give compound B, this is compound B. And compound B, when treated with chlorophyll, this is CH3CH2 NH2. When it reacts with chlorophyll in presence of alcoholic potash, it forms CH3CH2 NC. You can write NC like this or NC. This is one coordinate bond and two covalent bond. NC plus 3 KCl plus 3 H2O. So it has offensive cell or unpleasant smelling compound C. So this is compound C. So what is A? So acetylene reacts with a dilute H2SO4 and HgSO4 to form acetaldehyde. Acetaldehyde reacts with ammonia to form acetaldehyde, which undergo reduction in presence of sodium cyanoborohydride to form this compound, that is ethylamine. And ethylamine, this is ethylamine, and ethylamine treated with chloroform and alcoholic potash to form ethyl carbylamine or ethyl isocyanide. So A is acetaldehyde, B is ethylamine, and C is ethyl isocyanide. Next come to question number 3. An optical active compound A C5H11NO on acid hydrolysis gives an acid and ammonia. From that we can conclude that this is one amide. And again, when A is treated with bromine and potassium hydroxide, a compound is obtained which upon treatment with nitrous acid yields an optical active alcohol and nitrogen. From this it is again confirmed that this is an amide as it reacts with bromine and KOH to give an amine. And this amine treated with nitrous acid to form an alcohol. The alcohol gives positive iodoform test as this is an optically active compound and this is an optically active compound. From that it is concluded that alcohol is a secondary alcohol. This number of carbon atom is more, this secondary alcohol, and the OH group is present at the second position. The alcohol is a secondary alcohol. So alcohol is 2-degree alcohol and OH group present at 2 position. This is one condition. Iodoform test. What is the structure of it? Okay. So, and at this amide on treatment with bromine and potassium hydroxide, it forms an alcohol. So it forms an amine. Amide treated with bromine and potassium hydroxide, it forms an amine. And you know this amide, when treated with bromine and potassium hydroxide, that is Hofmann degradation reaction, it forms an amine. This amine has one carbon atom less from that of the parent amide. Hence, this amine has 4 number of carbon atom, and this amine, when treated with nitrous acid, it forms an alcohol, and this alcohol has also 4 number of carbon atom. So, alcohol is secondary, OH group present at 2 position and contain 4 number of carbon atom and 4 number of carbon atom. From that we can conclude. Hence, what is that alcohol? Containing 4 carbon and second position this OH group CH3, CH2, CH, OH, CH3. This is optically active as well as this can give iodoform test. Okay, this all secondary alcohol and OH group have 2 position that can give iodoform test. And this is when this is treated with nitrous acid. When amine treated with nitrous acid gives this alcohol, then what is that amine? That amine is CH3, CH2, CH, NH2, CH3. So you have to write these points. Alcohol is like this, 4 number of carbon atoms. This is the alcohol. This is the amine. This is the amine. Then what is the amide? This group NH2 group is converted from CONH2 group. So in this way the amide is CH3, CH2, CH, CH3, CO, NH2. This is the amide. Okay. Now we have to write all the sequence of reactions. Okay. So what is A? So A is this amide. What is the name of this amide? 1, 2, 3, 4. So that is your 2-methyl butanamide. So CH3, CH2, CH, CH3, CO, NH2. This is the amide, and this amide treated with bromine and potassium hydroxide. It forms this amine CH3, CH2, CH, CH3, NH2. And this amine treated with nitrous acid HO, NO. So this gives alcohol, and the alcohol is OH. Okay, so what are their names? This is 2-methyl butanamide, and what is the name of this compound? Butan 2-amine, and that is butan 2-OL. Okay, so this is the series of reaction, and what you have to write I have already explained. You have to write it point wise. Next come to question number 4. compound A having molecular formula C2H5O2N. So formula total carbon, hydrogen, oxygen given C2H5O2N. On treatment with tin and HCl gives a compound B. As the formula is C2H5O2N and are treated with tin and hydrochloric acid, from that we conclude that this may be an nitro compound. So according to formula, this may be an nitro compound. And this nitro compound, nitroalkane, when treated with tin and HCl, it gives an amine reduction reaction. B, which when treated with sodium nitrate and dilute HCl gives compound C. Again this gives nitrous acid, and nitrous acid gives an alcohol having molecular formula C2H6O. So this is an alcohol. And the compound C, when treated with sodium, alcohol reacts with sodium and the formula is C2H6O. Treated with sodium metal gives effervescence. So alcohol reacts with sodium metal to liberate hydrogen gas and sodium alkoxide, effervescence. And when treated with chromium oxide, that is chromic oxide, gives saturated aldehyde having two carbon atoms. So saturated aldehyde having two carbon atoms means that is only one aldehyde, CH3CHO. Okay. Effervescence gives saturated aldehyde having determine the structure of A, B, C. So this is CH3CHO, acetaldehyde, saturated aldehyde, and again, so structure CH3C double bond OH. There is carbon-carbon single bond, that's saturated. And this is formed by oxidation of C2H6O. That means this must be an alcohol and that contain two number of carbon atom. So what is that alcohol then? That alcohol is then CH3CH2OH. So this is the clue actually. The saturated hydrocarbon containing two carbon atom. This is the formula acetaldehyde. Then this is ethanol. Again ethanol is formed by reaction of one amine with nitrous acid. Then what is that nitrous acid? That nitrous acid must be ethylamine. So the amine is CH3CH2NH2. So amine is CH3CH2NH2. As the amine is CH3CH2NH2 and it is formed by reduction of tin and HCl, then what is the compound? That must be a nitro compound. So from this last clue, you have to go through the first point to reach at the first point. So this is your acetaldehyde, ethanol, and that is ethylamine. Then this compound must be a nitro compound. So this must be CH3CH2NO2. So C2H5NO2N. So this is, what is your nitroethane. So this is nitroethane. And nitroethane when treated with tin and HCl, what it forms? It forms CH3CH2NH2. This is ethylamine. And ethylamine when treated with nitrous acid, that is NaNO2 and HCl. NaNO2 plus HCl. This is HONO. It is from nitrous acid. So it forms CH3CH2OH minus N2 and minus H2O. So this is alcohol. And this alcohol when treated with Collins reagent, or it forms This chromium oxide undergo oxidation to form CH3 CHO. So this is ethanol and this is ethanol. Okay. So for today, up to this, next class we will discuss some analytical questions based on aromatic structures or aromatic amines.